Welcome to this explainer. I am absolutely thrilled you're here. Today, we're going to unpack a framework that, let's be honest, almost every Java developer uses, but very few truly master. We are going to completely demystify the so-called magic of Spring Data JPA and uncover those silent killers that are literally tanking your production performance. The visual style of your clean, object-oriented code often hides a much messier reality underneath, and we're going to expose it. Let's get right into it. JPA makes database access easy. That's exactly why it gets dangerous in production. Man, this quote just perfectly captures the double-edged sword of object relational mapping, doesn't it? The very abstraction that speeds up your development and makes your life easier completely masks the SQL realities underneath. And when you try to scale, well, those hidden realities turn into massive application crashing bottlenecks. Okay, let's dive into this. 101. Why that specific number? Because a simple, innocent-looking request for just 100 orders in your application can silently trigger 101 separate database queries if you aren't paying close attention. You write one elegant line of Java, and the framework does the rest, but what it's actually doing behind the scenes might just be hammering your database into the ground. So, here's our roadmap for today's deep dive. We'll start by identifying the silent killers, tackle the notorious N+1 problem, navigate some sneaky saving traps, discuss the real cost of overfetching, uncover hidden tooling misconfigurations, and finally, wrap up with some rapid-fire fixes to get your architecture production ready. All right, Section 1, the silent performance killers. In software architecture, the absolute biggest threat is often the one you literally cannot see on your local machine. Small development databases are incredibly deceptive. They act like the tip of an iceberg, completely hiding your bad fetch plans. A repository method that runs maybe 2 queries locally might run 202 queries when the result set grows in the real world. Flying blind without actually visualizing and verifying your SQL during development isn't just a minor mistake. It is the very first major performance bug you're introducing into your codebase. So how do we fix this blind spot? Well, before you tune anything, you must force Hibernate to show its work. You do this by setting generate statistics equal to true in your properties. You absolutely need to activate debug logging for org.hibernate.sql. And if you're lucky enough to be on Hibernate 6, you're going to want to use org.hibernate.orm jdbc.bind to actually see your bind values. Visually tracking your SQL output right there in your logs is step 1 to taking back control. Moving on to Section 2, the dreaded N+1 problem. This is arguably the most impactful, most common issue in all of Spring Data JPA. But before we solve N+1, we have to look at the error that usually causes developers to create it in the first place, the infamous lazy initialization exception. It is notoriously frustrating. It happens because JPA defaults to lazy loading for one-to-many and many-to-many relationships, which, by the way, is actually a good thing. But developers often try to access that associated data way too late, after the Hibernate session has already closed. Now, what's really interesting about this is how developers react. When they get that lazy initialization error, they panic. The absolute wrong fix is going straight into the entity and changing it to fetch type eager. Seriously, do not do this. It permanently ruins your performance because now you're eagerly fetching that data globally, every single time, whether the business logic needs it or not. The right fix, using a join fetch clause or an entity graph. This solves the issue for that specific query, loading all the data in one efficient round trip, without baking a terrible permanent fetch strategy into your entity's visual structure. But hey, here is a massive warning you need to hear. If you mix a join fetch on a collection with pagination, you are playing with fire. Hibernate literally cannot translate a SQL limit correctly when a join fetch multiplies the rows. So what does it do instead? It dangerously fetches all the data into memory and then applies the limit in Java. If you have a large table, this is a massive out-of-memory risk just waiting to happen. You absolutely have to use a 2-query approach or key-set pagination instead. Okay, Section 3, saving and updating traps. We spend so much time obsessing over how we read data, right? We completely forget the hidden dangers of how we modify it. Enter the save and flush trap. A developer updates a managed entity, and then, inside a loop, they call save and flush. Do you know what this does? It forces the entire persistence context to be flushed repeatedly. You are completely breaking Hibernate's ability to group similar JDBC statements together efficiently. Remember, managed entities are dirty checked automatically. You really don't need to manually force a flush for every single little change. Let's put a number on this. 5 flushes. In a source test run by performance expert Thorben Jansen, using save and flush in a simple loop resulted in 5 complete flushes, checking 20 entities and 60 collections. But when he simply removed save and flush and just let Hibernate's automatic dirty checking do its job, it dropped to just 1 single flush for 4 entities and 12 collections. It's the exact same database result, but with dramatically less work. Just let the framework do its job.
Next up, Section 4, the cost of overfetching. Overfetching is basically when your application politely asks the database for a glass of water and the database responds by blasting it with a fire hose. One-to-many defaults to lazy, which makes total sense. But many-to-one and one-to-one default to eager. Why? Well, because early JPA designers assumed requiring proxy support would just be too hard for vendors to implement. But today, this default is a terrible trap. It causes you to fetch relationships automatically whether your business logic actually needs them or not. You really should explicitly set all your associations to lazy. And this brilliantly illustrates why loading full entities for read-only screens is a massive waste of memory. Think about it. If you're just showing a simple visual list of customers on a web page, you do not need to fetch fully managed entities. When you fetch an entity, Hibernate has to store snapshots of it in memory, just for dirty checking. That is a massive overhead for a list you're never going to change. The ultimate fix here is using data transfer objects, or DTO projections. Fetch exactly the columns you need and skip that heavy entity lifecycle overhead entirely.
Let's look at Section 5, Hidden Tooling Configuration Traps.
Standard, supposedly helpful developer tools can completely sabotage your architecture without you ever knowing. First up, the Lombok at data annotation. It seems fantastic for reducing boilerplate, but it automatically generates equals, hashcode, and 2-string methods. If those generated methods touch a lazy-loaded association, they will silently trigger database queries every time you log an object or put it in a hash set. The fix? Exclude lazy entities entirely, or just stick to @getter and @setter. The second massive trap, Open Session in View, or OSIV. Spring Boot actually enables this by default. It keeps your database connection open through the entire HTTP request to prevent lazy loading errors in your view templates. But under high load, this puts immense, crippling pressure on your Hikari CP connection pool. You need to set it to false and handle your data loading explicitly in your service layer.
And finally, Section 6, Fixing JPA for Production. So the crucial point is synthesizing all of this into actionable, rapid-fire architectural best practices. First, use sequence over identity for your primary keys if your database supports it, because identity completely prevents Hibernate from batching your inserts. Second, use a set instead of a list for many-to-many relationships. If you use a list, Hibernate treats it like an unordered bag, meaning if you delete just one item, it might delete the whole collection in the database and reinsert the rest. Third, explicitly declare your database indexes for columns used in where or join clauses. JPA is not going to magically generate those for you. And finally, do not treat the second-level cache as a silver bullet to cover up bad SQL. It is a targeted fix for stable, measured hotspots only. Which leaves us with one final, provocative question for you to ponder. What is Hibernate actually executing in your local environment right this very second? The clean visual abstraction of JPA is beautiful for writing code, but it is absolutely lethal if you don't peek underneath the hood. I challenge you, go into your properties file, turn on your SQL logs today, and uncover the hidden queries lurking in your own application. Thanks for joining me on this explainer, and happy optimizing.